Hello there. It's time to draw an isosceles triangle. What we're going to do in this problem is find the midpoint of each side and then connect them all to form a new triangle. Now, it looks like this new triangle we formed is also an isosceles triangle, and that's what we're going to go about proving. So first step is to label my parts. The original vertices we'll call A, B, C, and the midpoints we'll call X, Y, Z, and then I know some tick marks too. That first set is true because X is a midpoint, and then over here the triangle is isosceles. So of course this whole length has to be the same as this whole length, and Y is a midpoint, so that one's the same as that one. So all four of these are going to match up. Now this last set at the bottom, this length doesn't have to be the same as these other lengths. I don't know that, or I chose to make AB and BC the same length. AC could be something else entirely. So this one's getting 2 tick marks. Alright, what do I have to go about showing? If I can get that this length is the same as this one, then this whole triangle XYZ is going to be isosceles. And this length is going to be part of a triangle. I need to compare 2 triangles. Now this triangle in here is not enough givens about it, so I'm going to look at those exterior triangles on the left and on the right. So we're going to try to prove that yellow triangle is congruent to the pink one. Let's build our rocket ship. Alright, a little bit lopsided there. In that final compartment, the octagon, let's put our goal statement. Now in our body, let's put the 2 triangles that we're saying are congruent, the yellow triangle. I want to be a little bit mindful here. I'm going through the path A to X to Z, so up the 1 and then down the nothing, so that needs to be up the 1, down the nothing over here, CYZ. Now note here that the XZ, that's going to match with the YZ over there. Those are the corresponding parts, but I'm not there yet. Why are these triangles congruent? Well, I have this side, and I have this side, but I don't have this side. Using a side-side-side argument would be begging the question, assuming my conclusion. I'm going to need an angle, and it all hinges on an angle in the corner. We showed in class that given an isosceles triangle, you have congruent base angles. So I know that angle down there, angle A, is congruent to angle C. So this one is going to hinge on side, angle, side. First side, those are congruent because X and Y are midpoints on isosceles triangles. Then we have the angle. This is true because the base angles in isosceles triangle are congruent. And then the bottom side. And this one's just because Z is a midpoint. All of this flows into those triangles being congruent by side, angle, side. And therefore, that little length up there, YZ and XZ, are congruent by corresponding parts of congruent triangles are congruent. This allows us to conclude that triangle XYZ is an isosceles triangle after all. Thanks for watching. Character and Scholarship for Life.